Okay, now vector number 5, this is also advanced, but I want to tell you about the application of these vector multiplication in physics. I use an example, it's work, as you know. Let's talk about work a little bit. Okay, F1 is a person who is trying to push this box this way and brings it to this displacement. And F2 is another person who is trying to hold it up, is trying to just pull it up, and is not even causing any movement. Actually, is trying to pull it up, but is not even pulling it up. So the movement is actually in this direction. This is the direction of the displacement. This is the displacement vector, and as you can see, the F2 does not have any component if in the dimension of the displacement, in the direction of displacement. So the person who is doing work for us and we are going to pay him is actually F1. We are not paying anything to F2. F2 is not doing any work for us. Or look at this case. We have a F bringing this box from here to here. Of course, this F have components. Remember when we would divide the force to its components, this is Fx. If you draw a perpendicular here, this would be Fx. And the same in here, you don't need that because this is the same thing. And this is, of course, Fy. So I don't need this F anymore actually, because these two can replace, and the addition of them can do exactly the same as F. So in these two components, the Fx is the one who does work for us. And you know how Fx is found? Fx is actually F cosine theta, because it's the adjacent. And if this is theta, of course, adjacent over hypotenuse, you know, the adjacent over hypotenuse is the cosine of theta, and in this case our adjacent is actually Fx and our hypotenuse is the F. Therefore the this F goes to the other side, it will be multiplied, so the Fx would be F cosine theta. So this is what I agree, and I know this is the case. So this is the one who does the work for us. The F sine theta does not do any work for us in here. The Fy does not do any work for us here. The Fx is the one which does the work for us. So if I want to find the work, which I know work will only happen if there is both force and displacement, and the multiplication of these two vectors is actually work. So I know that the work is actually F d cosine theta. And now let's remember our actually, now that we talked about work, let's remember our multiplications. We have two kind of multiplications: dot multiplication, dot product, which is in this case a times b, and the result is a scalar, and the other one is cross multiplication, which is a times b, and the result of this one is actually a vector. This is a scalar. So which one would be the work? The work definitely is this one, because work itself is a scalar. So F times displacement would be the work. This is actually the type of as you know, force and displacement, they are both vectors, so they cannot multiply to each other's like numbers do. They have to choose one of those types, whether dot multiplication or cross multiplication. Of course, this is the way they are multiplied to each other, and we saw it in nature. And this is actually how the dot multiplication is discovered. It's been seen in nature. So these mathematics laws are the laws of the universe. This is why this very important physicist and mathematician and philosopher Khayyam, who is also a great poet in medieval time, has said that the religion should be math, because it's absolutely true, it's absolutely correct. So I can also believe that because there is nothing you don't need to justify anything. Just everything is obvious, and everything is, this is actually the laws of universe. So now if you look at this, F times D equals actually work, and the work is a scalar quantity. And of course, as you know, everything makes sense in the definition that you have learned. Of course, this is what work is. And as you can see in here, if this thing is going to be moved by this force to going to this displacement coming here, as you know, the smaller the angle is, the more work this F will do for me. So if the F is smaller, if the theta, the smaller the angle is, so if this is displacement, if the F is smaller, if the F is zero, if the theta is smaller, so F is closer to D direction, the more work is done. But if the F gets bigger, I mean, not the F stays the same size, the theta gets bigger. If the theta gets bigger, as you can see, the component which does the work for us keeps getting smaller. And if the F gets, like the theta gets so big that the F is 90, the theta is 90 degree, if the theta increases to 90 degree, then this F would not do any work for me. This F will do maximum work for me. This F will do no work for me, and this is what cosine is. And here, as you can see, the theta equals 0 has the greatest cosine. The cosine of 0 is 1, which is the greatest possible, is the maximum possible for cosine. And the 90 has the smallest cosine because it's 0. The cosine of 90 is 0. And in between, as it gets bigger, the cosine gets smaller. So as theta gets bigger, the work gets smaller. So all of these things make sense, and now we can see that. And also something very important, F times D equals work, the same, D times F also equals work. And you can see that in some of the problem solvings, that in some of them is easier if you multiply this way, or if you find the component of F on D, as it's in here. In some other problems, you better find the component of D on the F. So this was one example of this vector multiplication.